Hello everyone, welcome back to my channel. In this video we'll be looking at this, the keyboard of the FS-A1, which is a very important part of the computer, and it's been a while since my last video because I've been quite busy working on this. I am disassembling Arkanoid. It's quite advanced now, it's about 90% done. Anyway, about the keyboard, today we'll be looking at the schematic and trying to understand how these pieces in here are used to read the keyboard matrices. So we have the connectors, one resistor set and one decoder and LS145. Let's do some electronics. Let's have a look first at how the keyboard is organized. And to do this, I'm having a look at the wiki at msx.org, the keyboard matrices layout, and I'm looking at the international matrix. The thing is that depending on the model of your particular MSX, you might have a different matrix, but for the moment let's just use this one as a reference. As you can see, the keyboard is organized in rows. Here we have 11 rows from 0 to 10, and in columns, and we have 8 columns, bits from 0 to 7. And in here, in this matrix, we have all the possible keys that you have in your keyboard. The way it works is that the engine continuously selects one of these rows, and once a row is activated, let's say that has activated this one, you have the keystrokes at each of the bits. Let's say, for example, that you would like to read the ESC key, for example. In that case, the engine is selecting each of these rows one at a time, and as soon as it's here, you would have in this byte, let's call it B, the keystrokes. So when a particular byte is 0, for example, let's say that we have 1 1 1 1 1 0 1 1, it means that the key is pressed. Let's have a look now at the schematic. If you look at NIGA's schematic, you will see here a representation of the keyboard matrix, and each of these lines are the activation lines for the rows that originate at the engine. Here you have the 8 bits which correspond to a row that are giving you which keys are pressed in this row. It is interesting to see that one row is activated, the engine is connecting this to ground. So let's say that we are activating this particular line, so we will put it to ground, and then you would see which of the keys are pressed, and it means that they are connected to ground. All these are connected together, but the other lines which are not selected one are not put to ground, so they are simply disconnected. So you can see here that the system is using a pull-up resistor. So if the key is not pressed, you will read 1. That's why you read 1 when the key is not pressed. And as soon as the key is pressed in that particular row, it will be connected to ground, and you would have a 0. In order to minimize the number of pins in the engine is not using one separate pin for each of the activation lines of the rows, but instead it's using a binary number of 4 bits, which will encode which is the line that it wants to activate. So if we go down here, we'll see that it's using this chip in here, which is an LS145. This is a decoder. So with these 4 bits in here, from YA to YD, the engine is telling which is the line that it wants to activate, and this chip will put to 0, which is the row that it's actually activated. Goes up to here, and finally you have in here the byte which is read by the engine, and it gives you which are the keys that are activated in that particular row. And this is the way it works. So the next thing that we'll do is to use the oscilloscope to have a look at some of the signals, for example bit 0 of the selection lines. Let's measure this pin in here, which is the bit A, the less significant bit, and if we measure it with the scope, we see this signal where we can see the 5 pulses, and we can see the frequency of one period, which is 28.4 kilohertz. Actually, the sampling frequency will be the double, because we are interested in the time where the signal is held high or low. So our sampling frequency for the keyboard would be around 60 kilohertz. The last thing that we could measure is when the engine is sampling the keyboard. As you can see in here, and I am scoping bit A, the engine is not always sampling the keyboard, so most of the time it's not, then it samples for a while and then it stops again. So what I will do now is to stop this measurement in here and try to see when this repeats. Okay, it's stopped. What I want to do is to squeeze these peaks into a single one, and to know where this squeezed peak repeats again, to know the period. So with the new scale we can see that the peaks repeat after more or less 30.2 milliseconds, which accounts for more or less 30 Hz. So the engine is sampling the keyboard 30 times per second, which is not bad and good to know. Well, that it was for the keyboard. I hope you enjoyed it, and see you next time.